All right, today we are going to do more practice with applications of right triangles. So to start off, we are going to talk about Pittsburgh Cannon Avenue. So this is a street here in the United States. It's the third steepest street in the world. So if you take a look, you can see that house is built on a slant here. So one section of the road has a 37% grade. To the nearest degree, what angle does the road make with a horizontal line? Well, if I'm looking here, and if I try to think about this road as a triangle, right? The angle that the road makes with a horizontal line, they're talking about the angle of elevation. So they're talking about this angle here. So that can be calculated by thinking about what grade means. So we learned back in middle school what 37% means. 37% is a representation of 37 out of 100. And when we're talking about grade, this is just representing our slope. And we know the slope of a line is our rise over our run. So we can represent this as rise over run on this triangle. So we are rising or changing our y values here by 37 when our run is 100. So now we have a right triangle. If we need to solve for the angle of elevation or the angle that the road makes with the horizon or horizontal line, I can solve for x by using trig. So let's go ahead and write up our SOHCAHTOA. Let's identify these sides of our legs. 37 is our opposite leg, and 100 is our adjacent leg, and that's going to be our tangent. So I write my equation. The tangent of x equals my opposite leg over my adjacent. And then the only way to unattach tan from x is inverse tan. If I do that to one side, I have to apply the inverse to the other side. So now I have x equals the inverse tan of 37 over 100. And now using Desmos, see if I can get this up here. We'll go over to inverse tan 37 divided by 100. So it says that we want to the nearest degree. Well, 20.3 is going to be pretty close or approximately a 20-degree angle. So there it is. So for the rest of the day, what you should be able to do is go through and just draw some neat labeled diagrams. We're going to find all of our answers to the nearest tenth. So that means we want one decimal place for all of our answers. You should be able to, at this point, draw right triangles for all of these and try to identify what sides are given, what they're asking us, and work through these problems. If you'd like to go ahead and pause right now is a good time for you to work ahead. Otherwise, I'm going to work through a couple of the problems with you. So whenever you're feeling stuck, the best thing to do is to draw out your right triangle. This is talking about damsel in distress is being held captive in a tower. Her knight in shining armor is on the ground floor below with a ladder. So you guys know how good I am at drawing. So here is my tower. And the knight's down here with the ladder. And to get to this window, right here, there's the ladder. So I can see that I have a right triangle in here. So when the knight stands 15 feet from the base of the tower, so the knight's going to be at the bottom of the ladder. So this right here is going to be our 15 feet. He looks up at the damsel at the angle of elevation. So this angle here, the angle of elevation is 60 degrees. How long does the ladder have to be? So we're looking for the length of the ladder. We'll call that x. So maybe to make that a little more clear here, I'll draw my triangle. This is my 60-degree angle. 15 feet here. We're looking for the length of the ladder x. We start describing our sides. This is our adjacent side and our hypotenuse, which is going to be our cosine. So I write out cosine of 60 equals my adjacent leg over my hypotenuse. When I have x in the denominator, it's a little extra work. So I'm going to put this over 1 and cross multiply. And then to get x by itself, divide by the cosine of 60. And that should give us our final answer of x. Put that in our calculator. And we get exactly 30 feet. So we need a 30-foot ladder to reach that damsel in distress. All right, the next one. A 12-meter flagpole casts a 9-meter shadow. Find the angle of elevation of the sun. Okay, here is my flagpole. If it's casting a shadow, that shadow is going to be on the ground. Shadows are on the ground. Let's make our right triangle. We'll start labeling. The flagpole is 12 meters. We know that the shadow is 9 meters. We're trying to find the angle of elevation of the sun. Well, this is our angle of elevation. We'll call that x. So if I'm standing in this corner here, this is my adjacent and opposite. So that's going to be tangent. So the tangent of x, my opposite leg over my adjacent leg. The only way to unattach tangent is to apply the inverse. If I do that to one side, we'll have to do it to the other. So x equals the inverse tan of 12 over 9. So we'll go back over here, go to function, inverse tan, go back to our main, 12 divided by 9. We're rounding to the nearest tenth, so this is going to be 53.1 degrees. All right, a fire department's longest ladder is 110 feet long, and the safety regulation states that they can use it for rescues up to 100 feet off the ground. What's the maximum safe angle of elevation? So now we're trying to figure out our angle. So let's think about if we had a building here. This is our ground. The longest ladder that they have is 110 feet. So here's my ladder again. That's 110 feet long. It says that it can rescue up to 100 feet off the ground. So that is telling us the height is 100 feet off the ground here. The angle of elevation, that's this angle here, so I'm going to call that x. This is our opposite and our hypotenuse. So that means we're going to be using the sine of x equals our opposite leg over our hypotenuse. To unattach sine from x, apply the inverse to both sides. So now I have x is the inverse sine of 100 over 110. So back here, inverse sine, 100 divided by 110. So 63.4 if we're rounding correctly. 65. 0.4 degrees. All right, number 4. The tallest television transmitting tower in the world is in North Dakota. It is 2,059 feet tall. If you're on a level ground, exactly 1 mile away, so that's 5,280 feet away from the base of the tower, what's your angle of elevation looking up at the tower? So I'll go ahead and draw out my tower in the ground. So there's my tower. The tallest tower is 2,059 feet. And if you're on a level ground exactly 5,280 feet away, we want to know the angle of elevation. We're looking here. So X, that's our angle of elevation. So standing here at X, this is our opposite and adjacent, which means we're going to be using tangent. So the tangent of X equals our opposite leg over our adjacent leg. Apply the inverse to both sides. That'll leave us with X equals the inverse tan 2,059 over 5,280. Inverse tan 2059 divided by 5280. We get 21.3 degrees. And I'm going to leave the last two for you to complete. So number 5 and 6 will complete your homework. You should get those done on your own.